Have you ever looked at a car and wondered how it moves? It's a fascinating thing, really. We put fuel in, press the pedal, and off we go. But how does it all work? What's happening under the hood to make that magic happen? Well, it all starts with the engine. This is the heart of the car, the powerhouse that makes everything go. It's a symphony of controlled explosions turning fuel into energy. This energy is then transferred to the wheels, making them spin and propelling the car forward. So buckle up as we take a fascinating journey under the hood, exploring the inner workings of cars and uncovering the secrets of how fuel engines and planet axles work together to get us moving. Now let's delve a bit deeper into the engine room. The most common type of engine you'll find in cars is the internal combustion engine. It's called that because the controlled explosions we talked about happen inside the engine itself. Imagine a small cylinder with a piston inside. When a mixture of fuel and air is ignited in this cylinder, it creates a mini explosion, pushing the piston down. This up and down movement of the piston is then converted into a rotating motion that ultimately powers the wheels. It's a bit like pedaling a bicycle, but instead of your legs pushing the pedals, it's these controlled explosions pushing the pistons. And just like different bicycles have different gears, cars have gearboxes that help manage the engine's power and send it to the wheels effectively. In the next section, we'll explore exactly how it does that. Right then, let's talk engines. Picture this, a big metal block with lots of shiny bits. That's your engine, the heart of your car. It's a bit like a mechanical digestive system, taking in fuel and air and turning it into power. Now these engines, they're not all the same. You've got your petrol engines, your diesel engines, even electric ones these days, but the basic principle is the same: controlled explosions. Inside the engine, you've got these things called cylinders. Each cylinder has a piston that moves up and down like a caffeinated jack-in-the-box. Now, every good explosion needs fuel, right? That's where petrol or diesel comes in. It's the engine's food, if you will. This fuel is mixed with air and then squirted into the cylinders. But it's not just about chucking fuel in and hoping for the best. The mixture of fuel and air has to be just right. Too much fuel, and you get a rich mixture, which can be wasteful and polluting. Too little, and you get a lean mixture, which can damage the engine. That's where things like fuel injectors and carburetors come in. They're like the chefs of the engine, making sure the fuel and air are mixed in just the right proportions for a perfect explosion. And once you've got the perfect mix, you need a spark to set it off. Section 3, the dance of the pistons. Now when the fuel-air mixture explodes, it pushes the piston down with a lot of force, but that force alone doesn't turn the wheels. We need to convert that up and down motion into a rotating motion. That's where the crankshaft comes in. Imagine a metal rod with a series of cranks like elbows sticking out of it. The pistons are connected to these cranks, so when the pistons go up and down, they push on the cranks, making the crankshaft rotate. This rotating crankshaft is the key to everything. It's connected to the gearbox, which then transmits the power to the wheels, making them turn and propelling the car forward. Right, we've got those pistons going up and down like a fiddler's elbow, but how does that actually make the car move? It's all about transforming that linear motion into rotation, and the maestro of this operation is the crankshaft. Picture a sturdy metal rod with these odd bent bits sticking out. Those are the crank pins. Each piston is connected to a crank pin. So as the piston shoots up and down, it pushes its crank pin, forcing the crankshaft to spin. Now this spinning crankshaft, that's the heart of the matter. It's the link between the engine's raw power and the car's movement. But before we can unleash that power onto the road, we need to tame it, smooth it out, and that's where the gearbox comes in. Right, we've got this spinning crankshaft raring to go, but we can't just unleash all that power onto the wheels directly. We need to control it, refine it, and that's where the gearbox steps in, like a conductor leading an orchestra. The gearbox is a clever contraption full of gears of different sizes, all meshing together. These gears allow us to adjust the ratio of the crankshaft's spin to the wheel's rotation. In other words, it lets us change how much power goes to the wheels and at what speed. You see, when you start your car, you need more power to get moving, so you're in a low gear. This means the engine can spin faster while the wheels turn slowly, giving you that initial push. As you pick up speed, you shift up to higher gears. Section 3. Taming the beast, the clutch's role. Now imagine this. You're at a standstill, engine running, but you don't want to lurch forward just yet. You need a way to temporarily disconnect the engine's power from the wheels, and that's where the clutch comes in. A smooth operator in the world of combustion. The clutch is a disc that sits between the engine and the gearbox. When you press the clutch pedal, you're essentially separating this disc, breaking the connection between the spinning engine and the stationary gearbox. This allows you to change gears without grinding those gears together. Think of it like this. The clutch is like a slip knot. When it's engaged, the knot is tight, connecting the engine and the gearbox, transferring power. When you press the clutch pedal, you loosen the knot, allowing the engine to spin freely without turning the wheels. Section 4, the driveshaft's journey, power to the wheels. Right, we've got the engine spinning, the gearbox doing its magic, but how does all that power actually reach the wheels? Well, it's time to introduce the driveshaft, the trusty messenger that carries the engine's might. The driveshaft is a long, rotating rod that connects the gearbox to the differential, which then splits the power and sends it to the wheels. It's like the backbone of the drivetrain, transmitting the engine's torque, that twisting force, to the wheels that grip the road. Now, depending on the car, you might have a single drive shaft powering the front wheels, the rear wheels, or even two drive shafts in all-wheel drive vehicles, sending power to all four corners. This long spinning rod is a marvel of engineering designed to handle high speeds and immense forces, ensuring a smooth and efficient transfer of power from the engine to the wheels. Section 1. The planet axle. A balancing act. Now, we've talked about the engine's might, the gearbox's cleverness, and the drive shaft's long journey, but how does all that power actually reach the wheels in a way that makes sense? That's where the planet axle steps in, a true marvel of engineering. You see, it's not enough to just spin the wheels. We need to be able to steer, to go around corners without losing control. That's where the planet axle comes in, allowing the wheels to turn at different speeds while still receiving power from the engine. Imagine this, you're driving around a roundabout. The inner wheel needs to turn slower than the outer wheel to maintain grip and stability. The planet axle allows for this difference in speed, ensuring a smooth and controlled turn. Forward and reverse, a change of direction. Right then, we've got the wheels turning, but what about going backwards? You can't just spin the engine in reverse, can you? Well, that's where the gearbox comes back into play with a little help from the reverse gear. The reverse gear is a special gear within the gearbox that changes the direction of the engine's rotation. When you engage reverse, the engine's power is redirected, effectively spinning the wheels in the opposite direction. It's a bit like flipping a switch, changing the flow of power from one direction to another. This allows the car to move backwards with the same control and precision as moving forwards. The differential sharing the load. Now, imagine this. You're cruising along a winding country road, taking those bends with grace. But here's the thing. When a car turns, the outer wheels need to travel a longer distance than the inner wheels. How do we manage that without the wheels skidding and fighting each other? That's where the differential, a true unsung hero, steps in. It's a clever bit of kit that sits between the drive wheels, allowing them to rotate at different speeds while still receiving power from the engine. Think of it like this. You and a friend are carrying a long ladder. If you walk straight ahead, you both move at the same speed. But if you turn, the person on the outside has to walk faster to keep the ladder straight. The differential does the same thing for your car's wheels, ensuring smooth and safe cornering. The people's car, a Beetle's tale. Right then, let's put these mechanical marvels into perspective, shall we? Let's talk about the Volkswagen Beetle, the people's car, a symbol of simplicity and efficiency. That little engine in the back, An air-cooled marvel it was. No water pump, no radiator, just pure, unadulterated mechanical simplicity. The engine's power, not much more than a lawnmower's output, was sent to the rear wheels via a 4-speed gearbox. And the planet axle, tucked away in the rear, it allowed the Beetle to negotiate corners with surprising agility despite its rear-engine, rear-wheel drive layout. It was a testament to clever engineering, proving that you didn't need a lot of horsepower to have a bit of fun behind the wheel. Section 2, Horsepower and Handling, a sports car's story. Now let's shift gears, shall we, and talk about something a bit more spirited. Let's consider a sleek, powerful sports car designed for speed and handling. Under the hood, you'll find a roaring beast of an engine with multiple cylinders pumping out hundreds of horsepower. This power is channeled through a sophisticated gearbox, often with multiple gears and lightning-fast shifts, to maximize acceleration and performance. The planet axle allows the car to carve through corners with pinpoint accuracy, transferring the engine's power to the road with minimal loss of traction. It's a delicate dance between power and control. And the planet axle is the choreographer, ensuring that the car stays glued to the road even at high speeds. Section 3, Conquering Terrain, the 4x4 saga. Right then, let's take this off-road, shall we? Let's talk about 4x4S, those rugged beasts designed to conquer mountains, deserts, and anything in between. These vehicles need all the power they can get, and that's why they often have large, torquey engines designed to pull them through mud, sand, and over rocks. The gearbox is equally robust, with low-range gears providing maximum pulling power at low speeds. With power going to all 4 wheels, the planet axles ensure that each wheel can rotate independently, maintaining traction even on uneven surfaces. It's this ability to distribute power to the wheels with the most grip that allows 4x4S to tackle challenging terrain. The planet axles, working in tandem with the differentials, are the unsung heroes of off-roading, ensuring that the vehicle keeps moving forward no matter how rough the going gets. Section 1, the Symphony of Motion. So there you have it, a glimpse into the fascinating world of engines, axles, and the intricate dance of gears that propels us forward. From the controlled explosions in the engine's cylinders to the clever mechanics of the planet axle, it's a symphony of engineering, a testament to human ingenuity. We've seen how the humble Beetle, with its air-cooled engine and simple yet effective drivetrain, captured the hearts of millions. We've marveled at the precision and power of sports cars, where every component is designed to extract maximum performance. And we've explored the rugged capabilities of 4x4S, those go-anywhere machines that rely on robust engines, clever gearboxes, and of course those trusty planet axles to conquer challenging terrain. But it's not just about the machines themselves. It's about the people who design them, the engineers who pour their hearts and minds into creating these marvels of mechanics. It's about the drivers who experience the thrill of the open road, the freedom of movement, the joy of getting behind the wheel. Section 2, the road ahead. As we look to the future, the automotive landscape is changing faster than ever before. Electric cars, with their silent motors and instant torque, are becoming increasingly popular. Hybrid vehicles combine the power of combustion engines with the efficiency of electric motors. And autonomous driving technology is poised to revolutionize the way we think about transportation. But even as technology advances, the fundamental principles of motion remain the same. We still need a source of power, a way to transmit that power to the wheels, and a mechanism to control the vehicle's movement. The engines might be electric, the gearboxes might be replaced by sophisticated software, and the planet axles might evolve into even more complex systems. But the underlying principles, the clever engineering, the pursuit of efficiency and performance, these will continue to drive the evolution of the automobile. So next time you're behind the wheel, take a moment to appreciate the symphony of motion happening beneath you. It's a testament to human ingenuity, a reminder that even the most complex machines are built on a foundation of simple, elegant principles.